So earlier in our class, we saw what NAT is. What NAT is, mostly people will say NAT is the translation of a source address from private to public. And when the return traffic comes, the reverse NAT happens. What does that mean? The reverse NAT means from public to private. So this is what most of the people will think about NAT. They are right, but that is not the definition. Definition is not private to public or public to private. Definition is like this: inside local translation of source address, the address that belong to inside local local, and then you got, so inside local means LAN network, and then you got a WAN connection to the internet where you have an address here or a subnet here. Let's say serial 0 interface, this is Ethernet 0 interface. So on serial 0 interface, there may be an address, or you may have a pool of address pool. We call that as outside local. Sorry, not outside local, I'm wrong. That is also called as inside, but it is inside global. Inside global. Because that belong to our router, the IP address belong to it, so it is still inside. Now anything from here is outside. So the translation of inside local address to inside global address is what called as NATing. Most of the time, the inside local address is private and inside global address is public. That is why instead of using this word inside local and inside global, everyone use a translation from a private source IP address to a public source IP address. So that's also okay to say. Now, our focus today is on types of NAT. There are 3 types of NAT in a router. Number 1, static NAT. What is static NAT? You give one private IP address, a dedicated one public IP address. One-to-one NAT. One-to-one NAT is what called a static NAT. What does this mean? You give 10.0.0.1. Let's say this is your LAN IP address of this computer, and there is another computer 10.0.0.2. So we translate these address by giving a dedicated address. For 10.0.0.1, let's say we give 20.0.0.1. For 10.0.0.2, we give a dedicated 20.0.0.2. So if you're giving one dedicated public address to each private address, we call it as one-to-one NAT or static NAT. In this, if someone wants to talk to this computer A from outside, what address they will send the packet? From someone outside. Someone is outside. If he wants to, he's in public. If he wants to talk to A, if he wants to send the traffic to A, communicate to A, what address he will use as a destination? So you didn't follow. Are you there? My question is, you are NATing from this IP address to this IP address, correct? Now I'm asking a question. If the C wants to talk to A, C is in public, to which address he will send the packet? ఏమండి 10 ప్రైవేట్ కదా, you are mapping to this address. According to C, what is the address of A? చెప్పండి. ఏమండి again, according to C, what is the IP address of A? Because you are mapping, you are already translating. C is in public. When C receives the packet, what is the address it will receive? 20001. The 10 is already removed, netted, mapped. So C only knows 20001. So if C wants to talk to A, it will put the address 20001 and send the traffic. And anything comes to 20001, the router will be forwarding to 10001 by changing the destination IP address. You understand? Here, destination IP address is changed. When packet is coming from outside, C is communicating to A. A is what now? When C sends to A, what will be the address? Again, I'm asking the same question. You are not answering. When C communicates to A, what is the source address and what is the destination address? Oof. What happened? You lost connection? That's why you didn't answer. I was talking to you. Okay, now question is, when C is communicating to A, what is the source address and what is the destination address? When C communicates to A, what is the source address and what is the destination address? Hmm. 80001 is the source address. What is the destination address? Again, you are not focusing, Kiran. I think you need a break. Is that true? Then why you are not telling the answer? What will be the destination address? C is talking to A. C is talking to A. What will be the destination address? How no? Correct. 20001. How C knows 10? 10 will, C will never know about 10 because router is what? Router is translating to 20. So now this packet will go to where? The router. Yeah? It will go to the router. Packet receives 20001. Now what it has to do? It has to remove this address and put which address? In order to send to A, yeah, it puts 10001. So what is changing here is not the source address, it is the destination address. You understand? When traffic goes from left to right, what is getting changed is source address. When traffic is coming from out to in, what is getting changed is destination address. Right, think about this nicely. So, static NAT is bidirectional. 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 If someone wants to talk from outside to A, they can talk. If someone wants to talk from inside to C, they can talk. If someone wants to talk from C to B, please tell me, if someone wants to talk from C to B, what will be the destination address? If someone is talking from C to B, what will be the destination address? Yes, correct, 20002. So the packet will now come from C to the router, and router will change to what address? Exactly. So both the side communication can happen, but the other two NATs that you are going to learn is unidirectional. Only static NAT is bidirectional. That's the advantage of static NAT. Static NAT is bidirectional. If someone wants to talk from outside to inside, you can talk because you got a dedicated address. For each inside address, there is a dedicated outside address. Means the public address, you have a dedicated public address. You can talk. You see, there's a dedicated public address. So you can just send the packet to the public address. The public address is going to send it to inside. This is one-to-one NAT. Static NAT is one-to-one. The static NAT has got a negativity. Means there is a problem in static NAT. What is that? I got two computers. I need two IP addresses to map. I need to buy two public IP addresses for two private computers. If I have 1,000 computers in my organization, then again I need to buy 1,000 public IP address, which is not possible. Why? Because we don't have IP address. IP address is only 32-bit, no, for the entire world. So even if you are ready to give money, they are not going to give us. That is why static NAT is used only for important services that you want to share from inside to outside. So, for example, you are launching a web server, meaning you have a computer, a big server, which is a web server, meaning you have hosted a web page here, and you want people from outside to use your web page. Maybe in the web page you are advertising some products, some nice kitchen decoration products, or you're advertising some food. These are all very popular business in India today, which makes more money. Food, construction material. So anyway, you are advertising your product, and people should come to the web page and see. So in that case, you may buy one public address, and you can dedicatedly map it to that, so that if someone comes from outside, they ping this address 20001 and they get the web page, the HTTP request. You remember in ACL class we put IP address and we got the web page. You remember? So For every computer in your organization, it is not possible for us to give a dedicated IP address. That is why we need to learn other two type of NAT which solves this problem. Even if you have 1,000 computer inside your organization, you can still have just one IP address, let's say 20.0.0.1, and you can have internet. Just one IP address. One IP address is enough for all to go online. Yep. So this is a very fine solution. You see, you don't need to buy separate IP addresses for every computer, the 1,000 computers in the organization. You just buy one IP address, that is enough. So now the second type of NAT that we are learning is what called as dynamic NAT. The dynamic NAT. And the third type we are going to learn is called as dynamic NAT overloading. Overload. Overloading. Dynamic NAT overloading. See, this both solves the same problem. What problem? You no need to buy 1,000 IP address. Even if you have one IP address, you will be able to manage. But there is a big difference between these two. But before I talk about this, I want to remind you one thing, that outside to inside communication is not possible. It is unidirectional. So only from this side to this side, NATing happens. Not possible from out to inside. No one can come from outside to inside. The big difference between static NAT and dynamic NAT is dynamic NATs are unidirectional, static NATs are bidirectional. What is the disadvantage of static NAT? You need to buy more public IP address. You need more mapping address because it's one-to-one. If you have 100 computer, you need 100 address to map. What is the disadvantage of dynamic NAT? What is the disadvantage of dynamic NAT? See, dynamic NAT is what worldwide used. Static NAT is also used here and there, but not for all computers, for one or two servers. We will have mixed of static NAT and dynamic NAT in production for the important server. For the important server which you want to allow outsiders to communicate, you will use static NAT. For all other computers, you will use dynamic NAT. Now, what is the drawback of dynamic NAT? It is unidirectional. Yes or no? It's unidirectional. Why, you know? Listen. So the disadvantage of dynamic NAT is it is unidirectional. It is unidirectional. Only from inside to outside, if traffic goes, the reply will come. But no one can talk from outside to inside. Listen, if someone talking from A to C, which is in public, the communication will happen. The traffic will go. It is coming from where 10.0.0.1. It will be NATed to 20.0.0.1, and C will receive packet. Tell me, when C receives the packet, what will be the source IP address? Listen, answer. Listen, answer. 20.0.0.1. Correct. Now, when C replies, what will be the destination address? 0.0.1. 1. And then router is keeping a track. Router knows that it has given this address to this guy. So it will remove the destination 20.0.0.1 and put the destination 10.0.0.1, and the packet will come to A from C. Yeah, not C from A, from C to A. Now, next time if B is talking to C, B will also be given the same IP address. You understand? Now, the reply will go to B. See, the same address is given, the 20.0.0.1 is given to both A and B. That is why we don't know what address to use to talk to B alone. You understand? There is no dedicated address for B or A. When A wants to go online, 20.0.0.1 is given. When B wants to go online, if 20.0.0.1 is not used by A, then it will be given to B. So there is no one holding this address for themselves. It is common. That is why it is called as dynamic. It can be used by anyone dynamically. If it is available, A can use, B can use, anyone can use. This D computer also can use. Listen, because this address is not given dedicatedly to any of the 10 network, any of the inside local, you cannot use the 20.0.0.1 to communicate to inside. When C wants to talk to someone inside, it won't be possible, because C don't know what address to use in order to talk to A or B or C. Sorry, A or B or D. You understood that point? Only if A talks, the return traffic will come. But C cannot initiate any conversation to A. C cannot initiate any conversation to A. Did you understand the statement? Okay, I have explained to you very well what is unidirectional. Now, the drawback of dynamic NAT is this. I told you there is only one address we are giving. If you give only one address, and if that address is given to D, let's say 30.10.0.0.3 is coming, it wants to talk to C. It is given by, it is mapped to this address. During this time, there is no other address for A or B to use. You understood? Because D is already using 20.0.0.1 and the conversation is still on, communication is going on, A and B have to wait because they don't have any address to get translated. So there will be a delay in conversation. If only one address is given, till that user finishes the conversation, still D communicates, A and B cannot communicate. To solve this problem, this dynamic NAT overloading is introduced. Did you understand the problem with dynamic NAT? Dynamic NAT, even though this address can be given to anyone inside, but only one at a time can communicate. You got it? If you say, no, I have two address, then what you can do is you can put the two address in the pool, 20002, 20003. Let's say you got two address in the pool. You can say these 1,000 computers can use these two address. So what will happen when D wants to talk? 20002, the first address from the pool will be given, and when 10.0.0.2, who is this? When B wants to talk, the next address will be given. What is the next address? 20003 will be given. Now when A wants to talk, is there any IP address left in the pool? No. So A have to wait. So whether you have more address or less address, the wait time is going to be there. There's going to be a wait time. That's the drawback of dynamic net. Advantage of dynamic net is you no need to buy 1,000 IP address for 1,000 computers. You can manage with one address, or you can buy 2 or 3 address, put it in a pool, and you can use it. Disadvantage is all 1,000 cannot communicate at the same time. If you have 2 addresses in the pool, only 2 can communicate at a time. Any two out of 1,000 will be able to communicate at the same time because you got 2 addresses in the pool. Now, what is dynamic net overloading? Dynamic net overloading. See, overloading means what? Overloading means what? Loading up more and more and more. Meaning, only one address is enough for all 1,000. 20001 is enough. Just one address. How beautiful, you see. All 1,000 IP addresses can be mapped to one single address. That's why it is overloading. You got it? Overloading. How is that possible? First of all, what is the challenge in this? Let us see. Listen. I told you dynamic net overloading is you will just use one address for all. If D is talking, one address is given. What is that? 20001. If B is talking, 10002 is what? B. For B also same address is given. And if A is talking, it's single address given to everyone. You understood? How is this possible? Listen. This D is asking for Yahoo. B is asking for Facebook. G is asking for Google. Now, Google, Yahoo, and Facebook, they are receiving the packet from which address? One, correct? Now all will be replying to 20001. Yeah. Aha. Google reply is coming, Facebook reply is coming, Yahoo reply is coming. Now how router will know, how router will know that I need to send Google to 10001, Facebook to 10, how you know? Same like this Y, F and G, there is a port number. When this is asking for Y, this is asking for Facebook, this is asking for Google. When this computer sends traffic, they send with some port number. Listen, this is like 555, let's say port number. Let's say Facebook is sending request from 10001 IP address and the source port number is, let's say, 7777. And 10001 is also having port number 9999. So what this router will do when it NATs, it uses this port number and say 555577779999. It copies the port number so that when Yahoo, Facebook, when Facebook replies, it will reply to 7777 because Facebook was sending a request with 777 port number. So when the reply comes to 777 of 20001, it will map this 777 with this 77 and understand Facebook should go to 10002. You understand? If the reply comes to 5555 of 20001, the traffic will go to which computer? D or A, B or C? D or B or A? If traffic is coming from Yahoo with a port number 5555, it will go to D because D only generated 5555 when it was sending a request. So what do we see here is, with the help of port number, the reply packet can be forwarded to the correct inside computers. Because the port number is involved. Because the port number is involved, this dynamic NAT overloading is also called as PAT. What is PAT? Port address translation. Port address translation. You understood the difference between three types of NAT? Now, first type is called a static NAT. Static NAT is one-to-one, bidirectional. The disadvantage is you need more public address, which is practically not possible. Next is dynamic NAT. Dynamic NAT is dynamic NAT, both dynamic NAT and dynamic NAT overloading, they are unidirectional. In both, you can map any inside address to one or more inside global address, to one or more public address. But the drawback of dynamic NAT is, if I have two address for mapping, only two can go online. Yeah, all the rest need to wait till the address is released. To solve the problem, dynamic NAT overloading uses the port number, so that with the help of port number, it can map the replies. It can map the service by using the same mapped address. So the translated address is same, but still the replies can be sent without any mess to the requester with the help of the port number that is generated from the requester. So the dynamic NAT overloading saves a lot of IP address. Dynamic NAT overloading, because it uses port number, it is also called as port address translation. You got this very well? I'll